So now the cancer has grown so much that it needs to find a place of its own. But in order to do that, it needs to first walk to the highway and hitch a ride. But cancer cells can't do that because the moment they step outside, they're going to get caught. Now, cancer cells don't have enough money in terms of ADP. So now cancer cells are going to steal something from the neighboring healthy cells, but that won't be ATP. They are going to use growth factors that the surrounding cells are secreting, and they're going to build up their own highway. And I think that we've just found a new part of Ocean's 11. But what's even more amazing is the cancer cells not only steal from normal cells, but they also steal growth factors from resident macrophages. As you can see in the diagram, there is a small mass of cells that is continuously growing, and what happens that an angiogenic switch occurs. This angiogenic switch means that now the cell is going to use factors to make blood vessels. In normal cells, this angiogenic switch is kept off, and there is a fine line between balancing pro-angiogenic factors and anti-angiogenic factors. So think of it that this way, that you do not want to always make blood vessels, but you also don't want to stop the production of blood vessels, because in case of an emergency, your inhibitors have to be replaced with activators. But in the case of a cancer cell, this balance is disturbed, and now your inhibitors no longer function because your pro-angiogenic factors switches on the mechanism for building up new blood vessels. Now think of it as this way, that you can't use the normal road to escape. So what are you going to do? You're going to escape from the back door. And this is exactly what these cancer cells do. The cancer cells make new blood vessels away from the normal blood vessels. So as you can see in this picture, that in the upper part, there are normal blood vessels, and you can look at them and they seem very healthy. Compared to that, blood vessels in the lower half of the picture appear very distorted and veiny and weird, and they're farther away from the blood vessels that normal cells use to gain nutrients. And now that we've got everything in place, here's the list of all the prerequisites before it can undergo metastasis. And all the 5 factors that you can see on the screen have been achieved due to Hallmarks I till IX. And now the final step of epithelial to mesenchymal transition will allow the cancer cell to move to another side of the body and grow and metastasize over there. And with that, we are going to start our discussion on the final hallmark of cancer, hallmark number 10, which is activating invasion and metastasis. Your invasion protocol begins when a cancer cell breaks off from the tissue and starts to move towards the blood vessel. And this movement of the cancer cell is called invasion, because that cancer cell is going to move from one place to another place of the body. This is awkward in 2 ways. For once a cell is differentiated, they remain in that part of the body for the rest of their life, unless and until those cells are clonal cells and that they can be regenerated. An example would be stem cells. So if I say that a cell from my hand would travel down to my foot, that's awkward, because cells in my hand are going to stay in my hand and continue dividing in my hand. But cancer cells, due to all of those mutations discussed previously, activate this process called epithelial to mesenchymal transition, which allows them to invade other areas of the body. But then, are there cells that can move along the body? Yes, there are cells like your immune cells that circulate your bloodstream that can act as scavengers. But then there are other sorts of cells, for example, the hematopoietic stem cell. And these stem cells have this unique homing feature. They move a bit away from their location, and then they're able to find their way back. But you have to keep in mind that homing is not invasion, because these cells can return back to their original positions. But a cancer cell, once it homes away from its base, it's not going to return back. Or you can say that its GPS is broken and it cannot find its way back home, and wherever it is, it's going to create a new home for itself. So this is a diagram representing epithelial to mesenchymal transition, and basically it's showing that your cancer cells have undergone mutations, And now they're going to detach themselves from the extracellular matrix, the sticky substance that's holding them in place, and then they're going to go around and try to find their way into one of those blood capillaries. So basically, this is the most simplest depiction of epithelial to mesenchymal transition, and I'm not going to go into details about all of the factors mentioned here, but all you need to know is that they leave the ACF, or the extracellular matrix, and then they try and move into the blood vessel, which brings us to the next step, that is called introverization. And introverization is basically the phenomena of a cancer cell entering the blood vessel. Now, there are two types of introverizations: active introverization and passive introverization. In active introverization, the cells detach from the basement membrane or the extracellular matrix. The other passive introverization is the entry of a cancer cell into a blood vessel. So even though EMT has been achieved, the cell has rolled off. Until and unless it gets into the bloodstream, it cannot enter this sacred domain of spreading more cancer in the body. And now comes the hard part. The moment a cancer cell enters the bloodstream, it's completely exposed. It's exposed to immune cells, to pathogens, basically everything in the blood. This cancer cell is totally at the mercy of the bloodstream, and it doesn't know where it's going to end up. This cell is now called a CDC, or a circulating tumor cell. Now, the CDC has to survive systemic circulation in order to reach a point where it can metastasize. And it's all about luck from here on out, because the CDC can run into an immune cell, it can end up in the lymph node and get digested by immune cells, or it can reach a tissue where it can lay groundwork and begin to metastasize and grow. So this welcome party in preparing the space for a cancer cell is prepared by these weird cells called exosomes. But these are very weird cells because they have DNA on the outer surface. What has been observed is that whenever these cells are found in a certain area, they are an indication that a cancer cell might metastasize there. And prior to last year, I didn't know about their existence, but the cancer conference that I attended, I got to know about how these cells are now being considered for diagnosis and prediction of metastases. And with that, we are going to wrap up our Cancer Hallmarks series. Now, I've tried to keep these lectures very simple and avoid any technicalities or jargons. But if you want any more explanation, or if you have any confusion, please let me know in the comment. And if you're looking for resources regarding cancer, feel free to reach out to me on Twitter or in the comment section below.
Pas tu, pas tu, la vigne dit que je